Hello my dear students, I hope you have done that exercise of solution, and today we'll start our new chapter, that is electrochemistry. Electrochemistry is very important chapter from your board point of view as well as competitive exams point of view, NEET and IIT JEE. So electrochemistry, this chapter is basically relation, gives the idea about the electrical energy and the chemical energy. That means how can a chemical changes or chemical energy gives electricity or electrical energy, or how an electricity, while you are applying electricity to an cell, it changes the chemical reactions. Okay, how it will give the chemical energies. Okay, so electrochemistry, it is the relation between electro means electricity, electrical energy. This is chemistry which deals with the chemical reactions. Sometimes electrical energy gives chemical reactions, and chemical reaction or chemical energy will give electrical energy. Okay. So from where this idea came? So I will take you to the past. From the standard 8th, all of you have know that whenever the reactivity of metal series, you must be read in that standard 8, 9. So there you have done one experiment. Okay, where you have taken a beaker and you have added copper sulfate CuSO4, which is blue in color. Okay, there you have dipped zinc rod. Okay, so copper, this is blue metal, we know that 5s2o. so this color, blue color, when you dip this rod to this beaker or to the solution, what happens? The blue color disappears. Blue color got vanished. And what happens? The zinc rods start reducing. Okay, the portion which is dipped inside that solution, that got reduced. So what happened? When you have put a temperature thermometer here, what you will get? There is a rise in temperature as well. Rise in temperature. Color changes. Zinc rod reduced. And what? Color? Sorry, what? The temperature raised. But we have not got any benefit from here. Okay. So, in 11th chapter, 11th class, we read a chapter called Redox. What is it? Redox is where the oxidation and reduction reaction takes place simultaneously. So in this chapter, we will discuss about redox reactions. This is what the correlation. If you have not read, you have to be very clear about the redox reaction. Okay, if not, watch. So redox, what happened here? Zinc got reduced, blue color disappeared, but we are not get any benefit. To get benefit, what we did? We have taken two half cell. This is reduced now. So here we have taken zinc rod, solution is ZnSO4. Here again we have taken copper rod and solution is copper sulfate. Okay, and to detect the flow of electron, we have connected with a galvanometer, voltmeter, which is voltmeter and ammeter also. So Basically this is a galvanic cell, so I am telling you that galvanometer. Okay, so what we are observed here, zinc started reducing over here. How? What will be the reaction? Zinc rod dissociates to Zn2 plus 2 electrons here. Zn2 plus, Zn2 plus, Zn2 plus, and these electrons will be remain in rod. Okay. Though it is connected, it starts flowing towards this end. So as this is electron based rod, now electron is there, so the electrode or the rod becomes negative charge, so this is what? Negative. Though it is going from this negative and to this side, then this side must be positive. Okay. So what happens here? Losing of electron, oxidation takes place. Yes or no? So electron moves from this to this side. This electron, when it reaches to here what happens? Copper and copper sulfate is there, and in the solution what are there? Cu2 plus ions are there, Cu2 plus and SO2 minus ions are there. So Cu2 plus ions will collect this electron and it deposits on the rod. Cu, that becomes Cu. So here what will be the reaction? Cu2 plus 2 electron, and it will form Cu salt. So this is known as redox. Okay. So this cell is balanced by a salt breeze. I'll tell you what is salt breeze, what is its function, everything. Okay, this cell is connected with a salt breeze. This is what known as salt breeze. Inverted U tube, which contains electrolytes, maybe KCl, NH4Cl, agar. So what is the role of salt breeze over here? Right? Salt breeze, the role of salt breeze, it maintains the electrical neutrality of the solution, and again it completes the circuit. We'll talk about electron, electricity, all these things. Okay, so this is known as galvanic cell. This is known as galvanic cell. Or voltaic cell, or electrochemical cell, or galvanic cell. Okay. So one of the important example of this galvanic cell is Daniel cell. This is Zn and copper, this one. Okay, so this is how you need to represent a cell, and this double bar is salt breeze. Okay, this is salt breeze. See, this is the cathodic part, or where the reduction takes place. This is Cu2 plus to Cu, that is what reduction or cathode, or this side is cathode, and this is what anode, where oxidation takes place, that is what anode. So this anodic half cell is also known as oxidation half cell, is also known as oxidation half cell, or you may also call this negative half cell because of the charge. Or left half cell. Similarly, the right half cell you can also call as reduction half cell, or positive half cell, or right half cell. Okay. So sometimes question may be asked that in anode what is the charge, in galvanic cell what is the charge of anode, or in electrolysis cell what is the charge of anode. Okay, so in electrolysis cell I will explain in that way, but here you just remember in galvanic cell the anode is negative. Okay, so for that you maybe remember this trick, you can remember this is this trick, LOAN, LOAN, left oxidation anode negative, left oxidation anode negative. Okay, so in case of galvanic cell. Okay, am I clear? So this is what your galvanic cell, this is what your Daniell cell, this is how you represent a cell. Okay, so this is galvanic cell, the maximum potential of this cell is 1.1 volt, remember. Okay, so what is the role of KCl, salt breeze? It maintains the electrical neutrality. How it maintains? Suppose KCl is there, suppose reaction starts, and in this side Zn2 plus concentration is increases. Obviously once you will dip Zn rod into this solution, what happen? The Zn ion plus ions will be dissociated here, yes or no? So Zn2 plus ion, so that the concentration of Zn2 plus ion will be high over here. But after few time it will not, if salt breeze will be not there, after few time this Zn2 plus ion will not allow these electrons to move over there, because it needs electron. As this solution concentration of Zn2 plus ion is high, it will not allow the electrons to move that side. So here what happens, this K plus and Cl minus ion, this Cl minus ion will come across this end and it will neutralize the solution and let the electron go to that side. Simultaneously here what happens, as Cu2 plus will be deposited over here, what happens, the solution contains negatively charged ions, yes or no? That negative charged ions will be neutralized by the K plus ions. That is how it will maintain the electrical neutrality. Okay, is it clear? Galvanic cell. Okay, let me clean these things. One more important thing is this, in the galvanic cell here the electron flows from this side to this side, that means the current flows is always opposite direction of the electron flows, yes or no? Yes. So this happens till the cell reaches 1.1 volt. The potential difference reaches to the 1.1 volt P external. Okay, suppose it reaches 1.1 volt, that means there will be an equilibrium, there will be no flow of current. Okay, if electron external will be 1.1 volt, there will be no current will flow. If suppose you have applied some external current, or okay, by connecting through a resistance, okay, if E external is equals to 0, is equals to 1.1 volt, then is no current flow in galvanic cell. Remember, okay, if it is less than 1.1 volt, right, so the flow of current is negative to positive. Positive, negative to positive. Okay, if E external is more than 1.1 volt, then it will be reverse, that is positive to negative, from this side to this side. Okay, is it clear? Suppose 1.1 volt, no current. Remember, if negative to positive, what? Electron will flow, the current flow will be, let me clear. Here no current. Okay, if it is 1.1 volt, okay, less than 1.1 volt, then the current flow will be, the electron flow will be from negative to positive, from negative to positive the electron flow. So as electron will flow from negative to positive, the current flow will be positive to negative. Current positive to negative. This is what electron negative to positive for this case. For this case it will be opposite, that electron flows from positive to negative, so the current from negative to positive. Okay, some electrolytic cell may this happens in electrolytic cell. Okay, we'll read there that time. Okay, so next some terms. Galvanic cell. What is galvanic cell? The cell or device which converts the chemical energy to the electrical energy. Okay, that is what galvanic cell. So next is electrode potential. Electrode potential terms. The potential difference, suppose it's a liquid or electrolytic solution, this is an rod, electrode, okay, this is one metal, and this is suppose solution, electrolytic solution, okay, electrolytic solution, okay. suppose this metal, so this metal oxidizes, means metal converts to Mn plus n electron, n plus n electron. Okay, so metal n plus to n electron. So what is electrode potential? So this metal has tendency to oxidize. Metal has some tendency to oxidize, and as it has some tendency, it will oxidize. It starts when you will dip, it will start oxidize. Okay, so there will be a difference as the time goes on. The potential or the power or the tendency will decrease or increase, yes or no? So there will be always difference. So at equilibrium means when the oxidation power will be stopped. At that moment, the potential difference between this electrode and electrolytic solution is known as electrode potential. Okay, the potential difference, right, the potential difference between whose electrode and electrolytic solution at equilibrium is known as electrode potential. Okay, right, quick. Okay, so if it is oxidized, there is redox reaction, means oxidation and reduction takes place simultaneously. Suppose this electrode is oxidized and another electrode is reduced. So oxidized means oxidation potential. The potential difference in case of oxidation half cell is known as oxidation potential. Oxidation electrode potential or oxidation potential. Okay, and if it is on reduction, then it is known as reduction potential. The potential difference between the electrode and electrolytic solution in case of cathode end, or where the metal goes reduced, then that is what? Reduction potential. If it is oxidized, then that is oxidation potential. Okay, and what? Standard electrode potential. One more thing is standard electrode potential. What is standard electrode potential? Electrode potential we know. The electrode potential under standard condition. The electrode EP, the electrode potential under standard condition is known as standard electrode potential. So now question comes, what is standard condition? Okay, standard condition, that you already know that the temperature, what will be the temperature? 273, wrong, 298 Kelvin, means 25 degree centigrade. The pressure will be 1 atm, and the concentration will be what? 1 molar. This is what? Standard condition. So the electrode potential under standard condition is known as standard electrode potential. Okay, am I clear what is standard electrode potential? Again I am telling you, the electrode potential under standard condition. What are the standard conditions? Where temperature will be at 298 Kelvin, where the pressure will be 1 atm, and the concentration will be 1 molar. Then this potential difference is known as, or the potential difference at standard conditions is known as the standard electrode potential. Okay, note it. Okay, so how will you represent standard electrode? This is Electrode potential capital E, or if you will write E naught, this is what standard. Naught stands for standard all the case. Okay, remember naught stands for standard all the case. So oxidation potential E, oxidation E M2Mn plus, this is oxidation. Reduction potential, what is this? E Mn plus 2 M. Am I clear? This is known as SRP, standard reduction potential. This is SOP, standard oxidation potential. Is it clear? Right, quick. Next is EMF of the cell. EMF, electromotive force of the cell, or it is represented as E cell. Okay, what is E cell? E cell is the, suppose this is what our galvanic cell, and two half cell is here connected, salt trees, and it has, this is oxidation, here it is reduction, this is cathode, this is anode. Okay, so it has some electrode potential, it has also some electrode potential. Okay, so the difference between the difference between two electrodes of the cell means the potential difference. What difference? The potential difference. The potential difference between two electrode of the cell is your EMF or E cell. So E cell will be your E cathode minus E anode. Okay. Or else you can write minus of E reduction potential plus E reduction potential. This is what your anode, this is what your cathode. So here is a confusion. Here again anode, here reduction potential, here even you have written that reduction potential. Is it? Yes. So here it is a confusion that relating to the reduction potential. Okay. So actually, if you write E oxidation potential plus E reduction potential equals to E cell, this is the formula. Okay, but when a metal, according to IUPAC always consider reduced potential or reduction potential. So SOP, standard reduction potential is standard oxidation potential is opposite of your standard reduction potential, opposite of, that's why minus sign. Okay, so here oxidation potential is nothing but minus of SR ERP, reduction potential. Understood? So remember this formula all the time. You are going to use this, or again you can write standard. This not stand for standard. E right minus E left. E right minus E left. Okay. All the case of standard. Standard means concentration 1 molar, condition, standard conditions. And how will you calculate without condition or on varying that concentration? That is what your Nernst equation. Okay, we'll go there. So simple. Remember, the potential difference between two electrode of the cell is your EMF of the cell, this. Okay.